towards a low carbon future. So I am Professor 𝗘𝗂𝘀𝗁, co-founder and managing partner at 𝗘𝗶𝗹𝗀 Inc. And I am also a professor of chemical engineering in Haldia Institute of Technology in West Bengal. So first we'll take a minute to explore what is 𝗘𝗶𝗹𝗀. So this helps industrial organization, engineering teams and sustainability leaders and climate tech professionals make better technical and investment decisions in low carbon technologies. So what we do, we enable clients to evaluate CCUS and hydrogen pathways with rigorous technical and economic frameworks and identify engineering, integration and project risk early, translate complex process decision into actionable strategies, upskill teams through tailored training and workshops, and clarify technology readiness for investment and scale. Our expertise is in carbon capture, CCUS system design and assessment, hydrogen production, storage and integration, techno-economic analysis and evaluation, risk evaluation, engineering training and competence development, and corporate workshop and executive seminars. So for this budget, the announcement by our Honorable Finance Minister 𝗜ጵ𝗱𝗀𝗬𝗀, so 20,000 crore allocated over 5 years for carbon capture, utilization and storage infrastructure development across key industrial sectors. So the part of the budget and then strategic focus is industrial decarbonization at scale. Net zero vision, it aligns with India's 2070 net zero target that Prime Minister of India declared a few years ago about net zero target of 2070. So why the CCUS matters in India? Hard to abate sectors like capture CO2 from steel industry, cement industry and chemical sectors where emissions are inherently difficult to eliminate through electrification alone. And then complements renewables. It works alongside renewable energy transition to create a comprehensive decarbonization strategy for India's energy mix. The dual objectives addresses climate commitments while enhancing industrial competitiveness in global market facing carbon regulations. So I'll come. So these are the 5 target sector. Power generation, according to International Energy Agency, globally around 81 to 82% of our energy demand coming from fossil fuels, coming from coal and natural gas mainly. So in power generation, steel production, cement manufacturing, and in cement manufacturing, the high emission calcination process where calcium carbonate is used as a raw material to produce calcium oxide and releasing carbon dioxide. And also cement manufacturing, this calcium carbonate to calcium oxide, this process occurs at 1450 degrees centigrade. So you need energy. So this energy you will be using fossil fuels. So from fossil fuel combustion also carbon dioxide getting generated. So we need to take care of both the carbon dioxide for cement manufacturing processes. In refinery, petroleum processes facilitates with concentrated CO2 stream. In chemical industry as well, petrochemical and fertilizer plants with significant emissions. So from Government of India, these are the 5 targeted sectors they are talking for this 20,000 crore funding. So why this kind of funding coming in 2026, not earlier or not later? So what is the drivers for this accelerating CCUS activity? EU carbon border adjustment. You know that recently Government of India was successful in doing a trade deal with the European Union, and you know that European Union has a very strict regulations and laws for carbon dioxide, carbon emissions. So European Union carbon border adjustment, impending tariffs on carbon intensive imports create urgency for Indian exporters to demonstrate emission reduction. Then export competitiveness will be another factor. It maintains India's positions in global market as carbon regulations tightens across major trading partners. And I want to share with you that last year COP, Cooperation of Parties, that is a multi-government discussion forum, where United States said that we don't want to do anything, but India, being a developed nation, is still going with its commitments for the necessary actions requirement for towards India's net zero target. Industrial growth, it enables continued expansion of manufacturing sectors whilst reducing environmental footprint and meeting climate targets. Technology leadership position India as a strategic player in emerging carbon management technologies and related intellectual property. So, and if you know that 18th century, India's contribution was around 24 to 25% in global GDP. Then India missed that industrial revolution, right? And in 1947, when we got independence from the Britishers, India's contribution in global GDP was roughly 3%. You see, in nearly 150 or 200 years, it came down to from 24% to 3%. So we missed the industrial revolution, and then in the software, the IT boom, we also missed that one, because Indian IT companies are mostly service provider, not the leaders in creating technology and all those things. And now it is coming artificial intelligence, robotic, this decarbonization. Now if we miss this boat, then again you can understand the growth of other countries compared to India's. Although we are fourth largest economy in terms of GDP, but in per capita we are far behind. We are like 2,400 or 2,500 US dollar per capita, right? So this technology leadership is very important in that context, right? So initial allocation and strategic roadmap, 500 crore initially allocated for financial year 26-27. It kickstarts pilot projects and feasibility assessment. And then we already launched a national roadmap for CCUS last December, and then it will be phased deployment, and then it will be commercial scale. So then, okay, so the technology and implementation framework captures at source. So we have two different kind of sources for carbon dioxide. One is stationary source, another is mobile source. So capture at source, where the industrial facilities like power plant, coal-fired power station, then steel manufacturing process, cement manufacturing process, refineries, etc. And then transport and then there are mobile sources like our transportation industry, but for them it is quite difficult. Now we are talking about CCUS. So carbon dioxide capture, carbon dioxide carbon dioxide capture, U is utilization, and S is storage. So suppose I have a power plant and I am generating carbon dioxide, and if I put carbon capture technologies, I will be able to capture that carbon dioxide. Then what I will do with that carbon dioxide? And for your information, globally we are producing around 38 billion tons of carbon dioxide, and we use carbon dioxide less than 1%, like around 550 or 600 million tons, not even 1%. Okay. No, not like that, 300 something like that million tons. Okay, so what we'll do with the carbon dioxide, and then carbon dioxide storage, it is generally stored 2 kilometers down the Earth's surface. Okay, and this storage site is not available at my source of carbon dioxide. It is available maybe few hundred kilometers away. So how to transport that carbon dioxide? Now, carbon dioxide is gas, it is in atmospheric pressure. We produce huge volume of carbon dioxide. So if you want to transport that carbon dioxide, we need very bigger diameter pipeline. Okay, so for that we need to compress that carbon dioxide, make it at supercritical carbon dioxide. So we compress it. So carbon dioxide capture, then compress and transportation, right? So we need to have transportation infrastructure. So generally the options for transportation is, one is pipeline, second is through train, third is through shipments, right? However, the cheapest one among all the alternative is the pipeline transportation. And then carbon dioxide utilization pathways. So carbon dioxide. So carbon dioxide is the lowest possible energy content between carbon and oxygen. Okay, so if that is the case, so in order to break that carbon oxygen bond, we need to provide huge energy. So if you want to produce something from carbon dioxide to formaldehyde or methanol or higher up, then we need energy, right? So from what that energy coming, and there are research and development work is happening. And then geological storage. So permanent sequestration in deep saline aquifer or depleted oil and gas reservoir with robust monitoring system. So this is the technology implementation framework. Then we in India, there are already few initiatives is underway, like NTPC 𝗖𝗍𝗀𝗀 project, where methanol production from captured CO2 at one of the India's largest thermal power station, demonstrating carbon to chemical pathway, carbon utilization. Then NTPC geological storage, they are also exploring that option. 𝗬𝗎𝐺𝐶 Gandhar CCS pilot project, integrated capture and storage demonstration at petrochemical complex, focusing enhanced oil recovery applications. Then steel sector trials in Tata Steel Jamshedpur, they are also using a solvent based carbon capture technology in their steel production process. Now climate economics consideration from different renewables, and then CCUS, etc. So balanced deployment strategy required. CCUS serves as a supplementary tool to renewable energy expansion, not a replacement, right? Whilst technology costs remain high and scalability question persist, strong regulatory safeguards ensure responsible deployment. So the strategic application will be CCS is most effective for unavoidable industrial emissions, where electrification or fuel switching is technically or economically unfeasible in the near term. So expected short-term targets for say next 12 months to 18 months. So it will be like pilot project launch, and then feasibility study, feed and detailed feasibility assessment will be done. Then policy framework like monitoring, reporting and verification kind of studies, MRV, standard established alongside regulatory guidelines for carbon management. So these are the legal aspects, okay. And then capacity building. So skill development programs and domestic supply chain strengthening to support India's CCUS industry growth. So these foundational activities will establish India's CCS infrastructure, expertise and regulatory environment, positioning the nation for accelerated deployment in subsequent years, whilst ensuring environmental integrity and economic viability. Medium-term impact for the next 3 to 5 years. Commercial scale units from the pilot will need to have the commercial scale, and then it will be shared infrastructure. For example, I have a capture facility, so I capture carbon dioxide, and then in my 100-kilometer or 50-kilometer radius, there are other facilities out there from different sectors, and then we want to store the carbon dioxide. So should we do alone to build those carbon dioxide pipelines, or we work together, build a network and then send together? So how we'll do that one? So of course, if we share, so cost per company will be less. And then carbon market integration. So seamless integration with domestic and international carbon trading mechanism, creating new revenue stream for early adopters. And then export competitiveness, enhance global market positioning through carbon neutral certification, meeting stringent European Union and US trade requirements for low emission products. Then what are the industry reactions? So overall a positive momentum, strong policy signal, government commitment demonstrate long-term vision and industrial decarbonization and climate leadership. Investor confidence boost, substantial allocation attracts domestic and foreign capital, de-risking CCUS ventures and encouraging joint venture. Private sector participation, so it will be PPP model. Catalyst enterprises partnership between public entities and corporation, accelerating technology deployment across cement, steel and refining sectors. So the concern will be in the cost structure. So question remains about capital expenditure, requirements, operational expenses and long-term financial sustainability of capture projects. And implementation timelines also, industry stakeholders express cautious regarding project delivery schedules, regulatory approvals and technology readiness levels. And now integrated clean energy measures like beyond CCUS, the government has also introduced complementary policy frameworks to accelerate India's comprehensive energy transition and manufacturing competitiveness. Battery source capital goods like custom duty exemptions on critical battery manufacturing equipment, encourage domestic safeguard. Solar glass duty relief, reduced import tariffs on specialized solar glass, lowered module production cost, strengthening India's position in global photovoltaic supply chain. Critical mineral support, strategic incentives for exploration and processing of lithium, cobalt and rare earth elements essential for batteries and clean energy technology. And nuclear import exemptions, extended duty waivers till 2035 on nuclear equipment and components, facilitate base load clear power expansion and advanced reactor deployment. So challenges and risk in financing and infrastructure. So mobilizing 20,000 crore demands innovative funding mechanism, including green bonds, concessional loans and public-private partnership. Developing CO2 transport pipelines and geological storage sites require extensive capital and coordination. And then regulatory clarity is required, clear frameworks needed for CO2 storage liability, monitoring protocol, carbon credit accounting and cross-state infrastructure rights to enable bankable projects. Technology maturity gaps. Several CCS technologies remain at pilot or demonstration stages. Scaling requires addressing capture efficiency, energy penalties, and integration challenges specific to Indian industrial conditions. Long gestation periods. CCS projects typically require 5 to 7 years from conception to commissioning, testing investor patience and requiring sustained policy support through political cycles. Overall look, 12 to 18 months is to validate and de-risk pilot project, commissioning, regulatory framework, etc. Then 3 to 5 years is scaling and commercialization, multiple commercial scale facilities, operational shared infrastructure network established and carbon market fully integrated. And then long-term impact will be millions of tons reduced, potential to capture 50 plus million tons CO2 annually, positioning India as a global leader in industrial decarbonization. Transformative catalyst, this 20,000 crore investment represents more than funding. It is a strategic commitment to positioning India at the forefront of clean industrial innovation, creating a replicate model for emerging economics worldwide. Now, We are, also training and consulting company. So currently we are running a CCUS training program, and our next will be starting in March. So it will be a 9 weeks program. It will be offered on Tuesdays and Thursdays from 8 o'clock to 9:30 in night in Indian time. And the topic will be CCUS from fundamentals to industrial plant design. So we'll explore different topics of carbon capture, storage, utilization, transportation, and then CCUS in cement industry, CCUS in steel industry, in refineries, in chemical industry, in power plant, and we'll design a carbon capture plant from the scratch. Okay, and we'll explore the career prospects as well. Yeah. So now the floor is open for discussion. And today we have Mr. Anindo Majumdar. So Anindo previously participated in the framing of the documents on CCUS published by Niti Aayog. So Anindo, if you want to share anything.
Yes, good evening, everyone. Fantastic session, sir. Thank you for your kind effort. So, I think this is a very basic structure that Government of India developed from their perspective to build up a net zero goal. At least the initiation already started. So, from that perspective, you have to consider what are the positive sources that can be captured and the competency we have to build up from our end as any form of engineering background to contribute our expertise to take the proper emission measures, right? So parallelly, we are doing some carbon monitoring that, say, from the steel sector. I think all of you know that they have selected a goal of 2.1 ton of CO2 per ton of steel, which can be measured. And if someone will give a less than 2.1 value, right now the value is in between 2.4 to 2.6. And someone, if any client who can propose to have less than equal to 2.1, so government will give some special incentive. So first step, I think, with parallelly, we have to build up our competency in the carbon monitoring, followed by the probable capture processes, and followed by how it can be utilized or stored. Because the U and S, both part are very, very critical. You can capture the CO2, but ultimately where you have to put in the EOR, saline aquifer, or you can utilize that part, that's the most critical thing. So we have to build up parallelly the competency, the knowledge, as well as the probable scenarios in upcoming 20, 30 years with respect to the carbon CO2 utilization. So as a team, I think definitely we can develop and contribute for upcoming 25, 30 years towards the net zero mission. Thank you, sir.
Yeah, thank you, Anindo. Yeah, what you said, it makes sense. So, people from any background, any engineering, any legal, any economics, marketing, sales, everybody is required here. Now we have Anup sir. Anything you want to share? Now we have Mr. 𝗖𝗍𝗪. Abhijit, you want to share anything?
Yeah, Dr. Uchal, this is very new and very, I would say, in a nascent stage as far as where India is concerned. Okay. But yes, good to see that a lot of studies are being taken place, and India is also taking an active participation in all carbon capturing, carbon storage, and utilizations. And this type of workshop, particularly the lectures, will definitely create an awareness among the people that what are the new technologies being developed across the globe, and particularly how we are going to modify our policies, Indian policies and Indian industry sector in line with global standards and minimize carbon emission and get benefit out of it. Thank you very much, Ujjwal.
Yeah,
This is a
thank
good
you.
evaluating session.
Thank you, Vijit. And Tanuj, anything you want to share?
No, sir, not at the moment. Maybe in future, if something comes up, I will contact you directly.
Yeah, yes, sure, sure. Ranak?
So thank you so much for sharing your input, sir. Looking forward to hearing more updates on it.
Okay, thank you. Anybody else? Yannick? Or Akshay? Or Amal?
Hello, good evening, everyone. It's a nice session, sir. So I am the first time to attend this carbon CCUS, and I'm working as a consultant. So it's helpful for us to these things within a short span because you have vast experience in this sector. So with your inputs, we can get a precise idea within a short time of frame. Thanks for your lectures. We will be attending and continuing with this such kind of session.
Yes,
Thank you, everybody.
yeah, thank you. Anybody else? Charumati? Or Neha?
Thanks for the session, sir. Actually, I have some network issues, so I just keep on getting disconnected. So I've just taken some of the screenshots of whatever you have shared. So we have to go through it and keep looking forward. And yeah,
Yeah, okay,
thank you.
thank you. And now we have Dr. 𝗖𝗿𝗀𝗀𝗀 from Singapore. Dr. Fahid, if you want to share anything about CCUS in Singapore.
Hi everyone. So firstly, I would like to thank Prof. for inviting me. So I have been myself. I am working at the National University of Singapore as an R&D manager. And before this, I was a senior scientist working in the area of CCUS energy transition. And I started working in the area of CCS with ExxonMobil in NUS back in 2019. And initially, the idea was to develop a small scale conceptual prototype where we can see if we can really capture and store CO2 inside the oceanic sediments. So we developed a small scale prototype on a very lab scale, which was only, I think, 770 milliliters chamber where we tried to sequester CO2 first as a gas and then as a liquid CO2. After that, we progressed on and we built a pilot scale facility, and we were able to determine that there is a strong potential of storing CO2 in the deep oceanic sediments. So this is what I have done. So I have been developing small scale prototypes, middle scale prototypes, and large scale prototypes for ExxonMobil, and definitely doing some lot of publications around. And Prof. Ujjwal was my mentor and teacher of reaction engineering back in Qatar University. And I have learned a lot from him, and it's always a pleasure to work with him and communicate with him. Thank you.
Yeah, thank you. Anybody else want to share anything? So we can see that for the next couple of years, lots of pilot kind of study, feed study, feasibility study will be there. Okay. So if you are working and if you want to, I mean, find another job, so I guess more job will be opening with this kind of roles. Maybe they will advertise externally or they will internally look for candidates. So please explore with your networks, with your seniors, with your colleagues, and we all know, and yesterday, because currently we are running a carbon capture certification program, so we are talking about networking is an important aspects of our professional or personal life, because 1 + 1 is always at least 3 or more, right? So if we network, then the ideas coming up individually, if we add, if we are talking 2%, the impact will be more than 3% in individual input. Sometimes it is 11, right? 1 + 1 = 11. If it is, the system is binary, kind of. So if there is no more question, then I think we should stop here. And I take this opportunity to thank you everybody for taking time from your busy schedule and attend this informative session. So we'll see you around in LinkedIn or personally, or in any future events physically. Thank you. Good night. Good night,
Thank you,
everybody.
Ujjwal. Thank you
so
Ujjwal.
much.
Thank you, bro. Thank you.
Conduct such events again sometime again.
Yes, sure. Thank you.
Okay, thank you.